let's move further with the next question. 10 raised to 4a plus 10 square a is equal to sec raised to 4a minus sec square a. So we'll start with our LHS. 10 raised to 4a plus 10 square a. We have written our LHS 10 raised to 4a plus 10 square a. Any idea, children, what am I going to do in the very first step? We have worked some sums where degree 4 got converted into degree 2 cos square. That's what I'll be doing over here. 10 square a, the whole square. Can I? Indeed. Degree 4, 2 2s are 4. Plus 10 square a, as it is. Now children, 1 plus 10 square a is sec square a. 1 plus 10 square a is sec square a. So what is 10 square a? Sec square a minus 1. So I'll just write down over here, only to make you understand. 1 plus 10 square a is equals to sec square a. So what is 10 square a, children? 10 square a is nothing but sec square a minus 1. This is 10 square a indeed. I'll write down this as sec square a minus 1. Sec square a minus 1. The whole square plus 10 square a. Now, can I say this is a minus b, the whole square? Answer is a square. So this becomes sec square a, the whole square is sec raised to 4a minus 2ab minus 2 sec square a plus b square. Children, here also we could have done the same, sec square a minus 1 plus, rather writing 10 square a, I could have also said sec square a minus 1. 10 square a. So wherever we have 10 square a, we are writing it via sec square a minus 1. Plus, I just need to open this and say sec square a minus 1. Children, sec raised to 4a plus 1 minus 1 gets cancels off. Minus 2 sec square a plus sec square a will eventually give me sec square a. Will eventually give me sec square a. That's what we wanted. That's what we wanted. Indeed. Am I right, children? That's what we wanted, which is my RHS. Since LHS is equals to RHS, I'll write down the entire question. Now, children, I just want one more solution over here. Method number 2. Only to make you all understand. As I said, couple of sums I'll be doing with more methods so that you should know how we should proceed with our thinking. How we should think, in what direction we should think in order to solve Trigo identities to prove sums. So this is method number 2 coming in your way. M2, method number 2. 10 raised to 4a plus 10 square a. That's what my LHS is, children. After understanding this sum, you will be surprised. Sir, this is the way we should think, and how did you do it very easily? Can I say 10 square a the whole square plus 10 square a? Now many must be thinking, sir, that's what you do in the previous one also. It's the same reiteration of the same step. Here comes a totally different thinking. Can I say this is 10 square a the whole square? That means there are 2 10 square a terms involved. Can I take 10 square a common? Can I take 10 square a common? So when I say 10 square a common, can I say I'm left with one more 10 square a? I'm left with one more 10 square a, 10 square into 10 square a, 10 to the power 4. Plus, since I have taken 10 square a common, can I say 10 square a plus 1? Now, what is this 10 square a, children? Can I say 10 square a is nothing but sec square a minus 1? And what is 10 square a plus 1? 10 square a plus 1 is sec square a. I'll just write down the same reason. What? 1 plus 10 square a is sec square a. And at the same time, you can say 10 square a is nothing but sec square a minus 1. Children, sec square a into sec square a, sec raised to 4a, sec square a minus 1, sec square a. That's nothing but my RHS, children. Don't you think so? That in the previous one also and in this sum also, we have given you two solutions which are more or less, you might think that they are running on the same lines, but yes, they have a different conceptual vision. I want my children to have this kind of visions. Kindly go through the solution.